Simplest radical form, worksheet number 1. Simplify the following radicals to the simplest form. So we got 8 examples here. To get started, I have the simplest of the examples on this sheet. Square root of 4, square root of 9, square root of 36 and square root of 25. Followed by these 4, which are square root of 8, square root of 45, square root of 72 and square root of 75. I would like you to copy all of them and then try to simplify them. Once you have done, then see my solution. Okay. Now here I'll teach you the technique of simplifying radicals. So let's start with the first row, which is square root of 4, square root of 9, 36 square root and 25 square root. So what is square root of 4? Now square root of 4 is 2, right? Everybody knows that. Square root of 4 is just 2. Why is it so? It is so because 2 square is 4, correct? So that is why it is so, right? 4 is a perfect square. That is another way of looking into it. 4 is a perfect square and therefore the square root is 2. How about 9? Well, 9 is 3 square, right? So 9 could be seen as square root of 3 square, and since it is a perfect square, we say square root of 9 is just the number 3. So that is a concept, you understand? Similarly, you could say, well, 36 could be written as 6 times 6, right? Now within square root, we have 2 6's, so we get the result 6 as the output. Do you see that? That's another way of looking into this. Square root of 36 is 6 times 6 or 6 squared, or simply it's the square of 6, so it has to be 6, right? Either way you reason it out, you get your answer as 6. 25 is, let's say 5 square is 25, that's what, and square and square root are reciprocal or inverse of one another, right? So they just return you what you get in. So 5 square root should be equal to 5. So we get our result. Well, in the first row, it is very interesting to see that all the answers you see are whole numbers. 2, 3, 6 and 5. What is 2 square? 2 square is 4, 3 square is 9, 6 square is 36 and 5 square is 25. So you have seen that at times when you simplify radicals, you may land up with numbers which are not radicals, right? That is most important to understand. So this is one case, not radicals. And that is the case when you're finding radicals for perfect squares, right? So that is the whole idea. The only way to simplify is to find a factor which is a perfect square. Now keeping that in mind, let's try to do square root of 8. Now square root of 8 can be written as what? Square root of 8 can be written as 4 times 2, right? 4 times 2 is 8. Now 4 is a perfect square. You could write this as square root of 4 times square root of 2. You know, square root of 4 is 2. So we get 2 square root 2 as the simplified form of square root of 8. We say it is simplified because now the radical square root 2 does not have any factor which is a perfect square. So the key here is to factor, right? To factor and find what? Find perfect squares. So that is what we have learned in this process. If you have a perfect square, then you could write it as a whole number. So square root of 4 was 2, square root of 9 was 3, 36 square root is 6 and square root of 25 is 5. But these numbers have factors which are combination of perfect squares and other numbers. So you land up with combination, mixed radical, right? You can call them as mixed radical, right? Which is right name. Now let's try with 45. Now 45 is square root of 9 times 5. So 9 is what? Well, square root of 9 is 3. So it's your choice. You can write like this also, or you can straight away write 3 square root 5. It is up to you. You could have written square root 9 times square root 5 and then next step 3 square root 5. Your wish. Right? I prefer at times not to stretch it too much. Now when it is square root of 72, well, I purposely wrote 36 to give you an idea that 36 times 2 is 72, right? So that helps. If you can find directly a number which gives you a perfect square as a factor, it's easy, right? So you get 36 times 2, and you know what is 36? 36 square of 6, right? So you could write this as 6 square, which you know, and then this is just square root of 2. So you get 6 square root of 2 as your answer, right? So that ways we can simplify 72. How about 75? 3 quarters, right? 3 times 25. 3 times 25, that means square root of 3 times square root of 25, right? Now 25 is a perfect square. 5 square is 25. So we could write this as 5 square root of 3. You will notice that most of the time, in fact every time, I wrote the number before the radical. Well, that's a standard way. I could have written square root of 3 times 5, kind of, not accepted. Better way is 5 square root 3. That is not wrong, but this is better way of writing, right? So whenever you write mixed radicals, write the whole number first and then the radical, right? So like this, you can always simplify the radicals. And when we say that the radical has been simplified, it really means that whatever you have under the radical does not have a perfect square as its factor. Then we say it is simplified, okay? So that is how we can actually do these questions. Now let me show you another way of writing square root of 72. I'll show you here, and I'm doing it on purpose since, you know, we knew 72 is 36 times 2 and it was kind of easy for us to get to the answer, right? Suppose if you don't know that 36 times 2 is 72, then what? Then you have to figure out all possible factors, right? So what you can do is, you can well, you know, 8 times 9 is 72, right? You know, 8 times 9 is 72, good. So 8 times 9 is 72, but 8 can be written as 4 times 2. So we can write this as 4 times 2, which is 8, and we already have 9 here, correct? Now 4 is a perfect square, 9 is also a perfect square, correct? So we could write this as, let me add one more step here. 4 is a perfect square, 2 is not, doesn't matter, and 9. So we got 3 different factors for 72. Now from here, I can write 4 as square root of 4 as 2, right? And then we have square root of 2, and here square root of 9 is 3. So when you get this situation, whole numbers here get multiplied. 3 times 2 is 6. And then we have square root of 2. So we can write this as 6 square root of 2. You can follow this path also to get to the same result. This is what I wanted to show. Well, this you could do with any number, right? Even with 8, we could have written 8 as 2 times 2 times 2. That will give us 8, right? Then 2 times 2, the first two 2's, one of them can be factored out. So that is an alternate way of looking into the same thing. But I hope you appreciate that to simplify a radical, we're trying to find factors which are perfect squares. Once you do them, right, then you have simplified your radical. That is what it is. For example, 75 is 3 times 25. So 25 is a perfect square, can be written as 5 outside the radical sign with 3 as the radical. So that is how we can simplify or write radicals in the simplest possible form, right? So what you learn from here is, 1, that radicals when simplified could be written as whole numbers. Radicals when simplified could be written as mixed radicals. And to simplify a radical, we are trying to find one of the factors at least which is a perfect square. And if we cannot find within radical any perfect square as a factor, then we say that it is the simplest form of the radical, right? So that is what is our learning from this video. And let's move on to worksheet 2 and 3 and perfect this process of simplifying radicals. I hope you enjoy it. Thank you and all the best.